Hello everyone, myself Aesha Joshi, lecturer in Electrical Engineering Department, VPMP Polytechnic. My subject is Analog Electronics. Unit name is Negative Feedback Amplifiers, and my topic is Current Series Feedback. My objective is to understand the circuit diagram of current series feedback amplifier circuit and to analyze the current series feedback amplifier circuit. Current series feedback circuit. This is the circuit diagram of current series feedback circuit. In this circuit, CE amplifier with unbypassed resistor RE. For this circuit, the sample signal on the output side is IO and the feedback signal VF is the voltage across RE. If we set the output IO is equal to 0, then the feedback voltage, this VF, is equal to 0, and so we can say that it is current sampling. The feedback voltage appears in series opposition with the source voltage, so this is series mixing. So current sampling and series mixing together will result in the current series feedback. So here current sampling and series mixers are used when part of a output current is sampled and given to feedback circuit where the fraction of current is converted into a proportional voltage and then given to input signal. And by this technique, input resistance bandwidth increases but the output gain is decreased. So this is about the circuit diagram of current series feedback amplifier. Now let's analyze the circuit, and to analyze this circuit we have to calculate its input impedance and the output impedance. So firstly we calculate the input impedance, and for that we have to draw the block diagram of current series feedback. So let us draw the block diagram of current series feedback. Here it is amplifier circuit. So its gain, from here we will give supply voltage Vs. This is our feedback circuit. Feedback fraction beta is equal to Vf upon Io. So here the part of output current is made to develop the voltage proportional to the output current and supplied back in series with the input. So here the input is in series, feedback network in series with the amplifier on input, okay, as well as at the output end it is in series. So let us draw in series. So here is the output. This is the feedback voltage Vf is equal to beta Io. This is our output. And this is our input. So this is the block diagram of current series feedback circuit. Now let's calculate input impedance. So from this block diagram we have Vs is equal to supply voltage Vs is equal to Vi plus Vf, the input voltage and the feedback voltage. So as we know from this equation, Vf is equal to beta Vo. So
putting the value of Vf in this equation, we will get Vs is equal to Vi plus beta Vo. But we know Vo is equal to A into Vi. So by putting the value of Vo in this equation, we will get Vs is equal to Vi plus beta A into Vi. So Vi will be common, so Vs is equal to Vi into bracket 1 plus A into beta. So input impedance, this as we know, Vs is equal to, let's see, here we know Vi is equal to IIZi. This is the equation of input impedance. So the input impedance with feedback, here we can write, we can put the value of Vi in this equation, then we will get the equation like Vs is equal to IIZi into 1 plus A beta. So we want the equation in form of input impedance with feedback. So Vs upon II is equal to Zi 1 plus A beta. Here this is input impedance with feedback. So we will write ZIF, which shows the input impedance with feedback, is equal to Zi 1 plus A beta. So this is our final equation, and this equation shows that the current series feedback increases the input impedance by factor 1 plus A beta. So this is about input impedance. Now let's calculate output impedance. Here for the output impedance, we have I is equal to IO minus AVI. But as we know, Vi is equal to minus Vf. So we will put this value of Vi in this equation, and we will get I is equal to IO minus AVF. Okay, and here we have Vf is equal to beta Vo and I is equal to Vo by Zo. So putting this value in this equation, here it is plus. Okay, so by putting I is equal to IO plus AVI, so by putting Vi is equal to minus Vf, then we will get the equation IO minus AVF. Now we will put the equation of Vf in value of Vf in this equation. We will get I is equal to the value of this I Vo by Zo minus A into beta Vo. Okay, so in this case we can write IO as it is current sampling. So therefore Zo is equal to I plus A beta IO. Now since IO is equal to I, since it is IO is equal to I, so we will put V upon Zo is equal to I plus A beta I. Okay, so we will take I common, so V upon Zo is equal to I 1 plus A beta. We can write this equation in this way also. V upon I is equal to ZO1 plus A beta. And this V upon I is the equation of impedance. So we can write ZOF, impedance of circuit with feedback, output impedance of the circuit with feedback. ZOF is equal to ZO1 plus A beta, and this is our equation of output impedance. So from this equation we can tell this, in current series feedback circuit the output impedance increases of an amplifier by factor 1 plus A beta. So here in case of current series feedback amplifier circuit, our input impedance, and this is our input impedance, and our output impedance both increases by factor 1 plus A beta. So this is all about current series feedback amplifier circuit. Now in next lecture we will discuss about the current shunt feedback circuit. Thank you.
Thank you.